you for having me today. And thank you for hosting this great session that we can exchange some ideas on ZK research. First of all, let me give a quick intro of myself. My name is Yue, and I'm the product lead of Brevis network. Brevis is a smart ZK coprocessor for the blockchain, leveraging zero-knowledge succinct proof. All right, you may have questions about what the ZK coprocessor is, why Web3 needs a coprocessor now, and what Brevis is about, and how Brevis is built. All these questions will be well answered today. Our team has been in this space for quite some time, and it is exciting that we have seen the explosive growth of the entire space over the past 5 years. We are seeing over 1,000 times of the total number of users increased, over 500K applications built, more than 32 billion US dollars venture investments, and more than 270 times increasing of the total value locked on chain, especially the growth of DeFi, which is the real product market fit moment of blockchain. As it shows the trust-freeness of blockchain, making a difference in the aspects of, for instance, the weeks of in-person meetings and negotiations in the traditional finance, to zero meeting and one click of mouth, and the relatively trust-free between the counterparties in DeFi. We also notice the public and permanent shared data on blockchain today are very valuable. On top of that, we should be able to build a lot of exciting data-rich and computation-heavy applications. For instance, the institutional KYC engine using both on-chain and off-chain data, the data-driven user lifecycle management, the privacy-preserving AI data exchange moderated by blockchain, and the new generation of user acquisition platforms for gaming projects. However, these applications are currently missing in the space, and the blockchain's full potential is not unleashed. It's mainly because blockchain is still functioning as the slow Web3 CPU. Well, this is kind of by design of blockchain. It offers the high trust-freeness, but at the same time, it also low performance, the high cost, and extremely computational expensive. There are still a lot of improvements to be done for sure. Even we can see now there are such a lot of layer ones and layer twos booming, but still they're relying on distributed consensus and bet at a data-rich and heavy computations. As an example, let's imagine if you want to build a user loyalty program for Uniswap. For instance, if a user has over 10K trades with 30 million US dollars volume for the past 30 days, the user should be granted as a VIP trader on Uniswap and can get 50% trading fee rebates. We can see this loyalty program in almost all of the centralized exchange, but not in decentralized exchanges at all. The reason is that it is extremely expensive to build natively in the smart contracts, as it needs to track and record every single trading transaction for every trader in the smart contracts. But you may ask, there's an option today that you don't have to build this in the smart contracts. For instance, we can remember the state roots of the blockchain by using a smart contract.
不是你不在。
But still we need to...
那服务器你什么时候能修好呀？
Sorry, I currently hearing some voices. Can you please just mute the others?
Yeah, I have done.
All right, thank you. So right, for instance, we can remember the state roots of the blockchain by using a smart contract, but still we need to calculate 10K Merkle proofs of transaction inclusion on chain. compute 10K RLP decoding on-chain to decode the transaction and look into the event, and then compute the aggregation of the decoded trading volume. And actually, we have calculated the cost on Ethereum for all these computations. It would take 4 hours of block time and 20,000 transaction fees. This is, we believe, not acceptable. Well, just like the CPU's evolution in the computer science history since 1970s, despite the explosive growth in the computational capacity, CPUs are still fundamentally bad at floating point arithmetics, bad at homogeneous parallel execution, and bad for anything visualization. That's why people started to build the CPU coprocessor in 1980s, which is called GPU. The development of GPUs has brought revolutionary changes to both the computational capacity and visualization of computers and Web 2 applications. And similar, we also believe a coprocessor is also needed for the blockchain. And basically, the coprocessor will handle the heavy computation task from the blockchain and return the results back. And blockchain should only focus on the transactional computation that is the synchronized in nature, and the entire computation process matters. But the coprocessor will process the data-rich and heavy computation and return results without recording the process of the computation. However, please note that introducing the coprocessor will not compromise the trust-free nature of blockchains. That is why it is not working if the coprocessor is built just with a simple centralized server. And we have built Brevis, which is a blockchain coprocessor leveraging zero-knowledge proof so that it is still trust-free in nature. Brevis can run arbitrarily complex computation on any data and generate ease to verify attestation for the blockchain. For the computation result. The dark magic to make this computation migration work is the zero-knowledge succinct proof. It is a technology based on cryptography that allows one to prove certain statements without revealing any information other than the fact that they know it. So it is trust-free from centralized server. Its only trust assumption is that the underlying cryptography can be proven to be mathematically sound. Well, let's go back to the previous example. So with zero-knowledge proof, we can now calculate microproofs of states or transactions off-chain and compute across all relevant states and transactions off-chain, and only need to verify a single zero-knowledge proof on-chain. In addition to that, we can also sync one blockchain's state to another blockchain by doing the consensus computation off-chain and relaying the ZK block header proof to the destination chain. And the proof will be verified in the on-chain verifier contract, and then to feed the verified state data to the DApps. Here you could see how the overall architecture of Brevis looks like. Actually, Brevis is an open infrastructure. In the lower layer, it is Brevis core, which contains the highly optimized ZK cryptographic proof engine that can sync the blockchain's data and generate attestations. And on top of that, it is Brevis API layer that is public and flexible for developers to integrate, so that builders are now able to build different applications use cases. Well, back to the example of Uniswap VIP Trader program. It can be built with Brevis, but while saving a great amount of cost. Okay, but how did we make this happen? And what is the secret sauce? So if to look into Brevis core and its components, it mainly includes the ZK prover network and ZK proof aggregator. And Brevis core is the key layer that is connected to all blockchains and potentially some other data source. then to ZK proof the required data off-chain, and feed back the verified information back to the blockchain. The prover network implements circuits for each blockchain's client protocol. This network generates validity proofs for block headers, and provers can leverage accelerators such as GPU and ASIC to minimize proving time and cost. Regarding the current one implemented prover and the circuit can be explained a little bit in the next page. Another key component is the ZK proof aggregator, which acts as the aggregation and a storage layer for ZK proofs and verify the results. It needs to relay the generated ZK proofs from the prover network and aggregates the proofs and verifies with efficient folding recursion. And then it will feed the requested verified results or ZK proofs back to the blockchain. Well, Brevis core is built with research-driven cryptographic algorithm. Our current implementation is using the batching technique and will evolve to aggregation and folding techniques. We implemented circuits in Gonarch with growth 16, instantiated with BN254. The circuit first calculates the ZK-friendly commitment and compares it to the on-chain commitment mapping. More specifically, it verifies the BLS 12-381 signature involving hash-to-curve calculations and BLS 12-381 pairing over the BN284 scalar field. Also, we can build the customized sub-circuits for common operations based on the use case. We are also now working on the improvements in proving time for a batch of signatures through hardware acceleration, so that to escalate the multiscalar multiplication and faster Fourier transformation. And on top of Brevis core is the API and SDK layer. And there are already APIs and SDKs available, such as the transaction proof API that can prove the transaction itself, and the receipt proof API that can decode and prove the events in the receipt, and also the slot value proof API, which can prove the blockchain's storage slot value, and also the message bridge API. And Brevis has been live on Ethereum mainnet and rolling out exciting products and partners. For instance, the Brevis Insight. It is a first-party application of Brevis coprocessor platform. It can do trustless data computation for the on-chain user lifecycle management. Let me now show you a short video and present what this is about. All right. Well, besides that, there's another interesting use case has been built on Brevis, is the Uniswap VIP discount hook, which is built together with Uniswap Foundation and just launched this month. All right, so this is about the Uniswap Wafer VIP discount hook that we have been just developed and built together with Uniswap team. But besides that, some other products are also live today. For instance, the Seller ZK bridge powered by Brevis ZK led client from Ethereum to other blockchains. So this is the truly trust-free bridge. And also we can now generate the ZK proofs of the user's social and financial connections on chain. This is something that you are able to try it out in our demo. And also some other use cases are still in development. For instance, the ZK data quality evaluation platform, so that we can build a real privacy preserving data marketplace. And also the ZK DID and anti-sable attack solution by generating the ZK proofs of users' identities based on their previous on-chain behaviors. For instance, if this is a old account age with a really high transaction fees, and also this is a real active users for related protocols. So in this way, to recognize the real users instead of the bots. Also for gaming applications, it can support to build user acquisition and incentive program by generating the trust-free proof of post-acquisition revenue and user behavior, as well as the smart wallets with social recovery feature based on the on-chain behaviors, especially for the AA wallets. We can help to build the kind of the smart social recovery feature based on the user's previous transaction history on chain, and then just to do the social recovery feature based on their, for instance, their old transactions or their connections with other users or friends. So in this case, it will be the real smart social recovery feature. So that is basically all about ZK Coprocessor and Brevis. We are also currently looking for early partners to build any interesting use cases together. So feel free to reach out and connect. Thank you.